When you take any set of data and you're wanting to analyze it, there's a few basic features that you have to have every time. Number one, you've always got an independent variable and a dependent variable. So the independent variable we know are the different groups that we are comparing or the different time scales that we are measuring. It's the thing that goes along the bottom of your graph, the thing that you are specifically changing, whether it's time passing by and you're measuring something changing over time, or whether it's different groups of things that you are comparing to see if there's a difference. So there's your independent variable, and the dependent variable is, of course, what you're measuring to compare them. So when you have a set of data like this, at this level, you need to have multiple measurements somehow done so that you can look for error. Now, multiple measurements can be done in several different ways. You can do the experiment several times and measure it exactly the same way, or you can do the experiment once and measure the outcome several times to make sure that you're measuring it correctly. Either way, you're getting multiple measurements to compare to each other and to work out standard error. So I'm just going to fill in this table a bit so we can look at how we then analyze that data to figure out the error in it. Okay, I filled in this table, and you'll notice up the top I've got these numbers here in bold. That's because when you take multiple measurements of one group, we call them trials. Each different measurement is considered a different trial. So that's the numbers of each trial that I've put up the top there. Don't confuse them with the numbers below. We might make them a slightly different color. So they're my different trials, and here are the measurements within them. Now, the basic scenario I was thinking of when I made this was teenagers and the number of hours they've slept each night and their level of activity. And as you can see, we've got all of these trials, and this is an awful lot of data, and it will make no sense if we don't get some averages and if we don't get some graph pictures out of this data. So the very first thing you want to do is add your averages. So to do averages in Excel, it's actually quite easy, or Google Sheets, they all do the same thing. Instead of you actually working out, all you have to do is type in the correct formula. And formulas always start with equal signs, and then usually the keyword, in this case average, AV, will bring up all of the different types of formulas it has preset. The one you want here is just normal average, numerical average of a data set, ignoring any text. So click that and it'll say, okay, what range do you want me to look at the averages for? I want it to look at the averages of all these numbers for this one, all of the trials for this one variable. So I will just take my little cursor here and go across here to say I want all of this range here. I will close the brackets to tell it I've ended and go enter, and it will give me an average. Now, to save yourself time, you don't have to type that in every time. If you then go, click that, get that little cross coming up there, if you put your cursor on that little dot there and go down, it will actually copy the formula but apply it. If I click that, it will apply it to the next line down. So it'll assume you don't want to do the same line, you want to do the average of the next line down. So that saves an awful lot of time. If you've got long numbers like this, you can also reduce them by saying, I don't want so many decimals. That's these little things up here. Decrease the number of decimal places, usually down to 2 or 3 in science at this stage. Now, averages are fine, but I want to know what type of spread I had in my data. This one here ranged from 1 up to 4. My average was 2, but that's actually quite a big spread away from an average of 2. So we have to look at a few other things. We call it standard deviation, and then also standard error. Now, I'm going to actually take you through a few steps to work these things out. So I'm going to get you to, in all of your tables, put the following columns: standard deviation, count, and then lastly standard error. And these columns are quite important to get a picture of how good your data is. So standard deviation is easy. Again, the formula is already in Excel. Just go equals STD and it will bring up this standard deviation. Don't worry about the rest of these. They're for higher level stat stuff. Click that one there, STD EV. And again, it says, what values do you want me to look for the standard deviation of? This is a measure of the spread away from the average. So again, I want to highlight that row or data set. Whoops, it's not doing it very well there. I want that whole line there because I want all of the numbers for 4 hours of sleep. I want to know the standard deviation. And it will come up again with a spread count here. Now, to make this easier on yourself, copy that down and it will work out the standard deviation for all of the numbers and reduce the decimal count down to 2 or 3. Now, whenever you're getting towards this standard error calculation here, you don't just need to know the standard deviation, but you need to know how many numbers are in your data set. In other words, how many trials. In this case, I know it's 9, but sometimes your data set can change. You will often not always have the same number of numbers in every data set. So it's actually quite easy to get Excel to count it for you. Go equals, count, and it will bring up these options. Now don't worry about the rest of these ones here. They're for high level Excel use, or in this case Google Sheet. Just go count, and again it says count what? I want it to count all the numbers in that line. It will ignore text. And then brackets to close it, enter, and it counts 9. Now again, if you want that formula to be used for all of the different independent variables, copy it down and it will count each line. Okay, the last thing we're going to do here is work out standard error of this data. So the one thing that Google Sheets and Excel don't have is a formula for standard error, so you're going to have to put this in. So standard error, and I'll write it down here so you can see. Standard error is the standard deviation that you've worked out divided by the square root of your number of data sets, or your count. So to put that into Google Sheets or Excel, go equals, and I've already worked out my standard deviation. You can actually get it to calculate it, but this is much easier. Click on your standard deviation, divided by, which is the line, the /, divided by a square root of my count. So the square root of 9, which in this case, square root of 9 is 3. But I need it to calculate that. So I go SQ for SQRT, find the square root of a number, and it'll say, okay, square root of what number? I want it to have the square root of whatever I have counted, that value there. Close brackets, done. There's your standard error. So once more, I want you to copy that down, and we'll also reduce the number of decimal places to make it easier for us to interpret later. Now you're going to be using this information to analyze your data and see whether or not your data is valid, whether it's reliable, whether or not there's little measurements in here that are obviously really bad and should be ignored. This is the reason why I got you to put in this count column here. If I can find a piece of data that I think really is bad, say this last one here might be say 17, well, it just ups my standard error and everything by a huge amount and is completely out of the trend, as you can see here on the averages. And considering all the rest of the data, that's an obvious error. So if I want to completely ignore it, I can either delete it or turn it into text by going like this around it with your little points there. And then it actually ignores that piece of data there, thinks of it as text. It's ignored it, changed the count to 8 because now it's only counting those pieces of data. I still know what was there beforehand, but it's not using it in the calculations anymore, and it brings all my standard error back into a reasonable range. So this is how you set up a table so that you can not only easily calculate the standard error, but play with your data, take data out if you think it has error in it, but still know what that data was, and then you can go ahead and make a graph from this data.